Welcome, and we are going to continue evaluating trig functions using a second method. All right, so we have a prompt here. It says evaluate trig functions at 5 pi over 3. Okay, fine, in at least 2 different ways. Okay, that's new. Okay, let's just evaluate trig function at 5 pi over 3 as we know how already. Okay, so again, if you need to make a little sketch, or pull out your unit circle, always a good idea, but we would have a unit circle. 5 pi over 3 would be down in quadrant 3. Okay, so let's see this. So this would be the 5 pi over 3, 5 pi over 3. I'm drawing it as an angle, right? But as long as we're in radians, we can think of this as our t, our trigonometric, or our trigonometric point, right? We can, and then this would be the point 1/2 negative square root of 3 over 2. My sketch maybe isn't the greatest, but we got the idea. We got the point, we got a rough sketch, good to go. Okay, so then I can come along and say sine, cosine, tangent, blah 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 of each or of this angle, just using the coordinate, right? So we know that sine of 5 pi over 3 would be the y coordinate, negative square root of 3 over 2, and then cosine is 1/2. Tangent would be negative square root of 3 over 2 divided by 1/2, which would come out to be just negative square root of 3. Cotangent would be its reciprocal, negative 1 over square root of 3, which would simplify to negative root 3 over 3. Secant would be the reciprocal of cosine, also known as 2, and then cosecant would be negative 2 over square root 3, which would rationalize to negative 2 square root 3 over 3. So now I have the different values of the trig functions in one way, right? I use the trigonometric point. How in the world do I do this a second way? Good question. Here's what I can notice. Previously, we talked about a trigonometric point and its corresponding angle and all that stuff. We talked about reference angles and reference numbers, right? So if we think about that in this problem, okay, I just blew the picture up a little bit. If I look at the reference number, right, that would be this t prime right there in red, and it would correspond to this reference angle theta prime, okay? So, okay, well, how much theta prime would be how much? Well, it would be whatever I need to get to the positive x-axis in this case, pi over 3. And then since it's in radians, this would also be our t prime, our reference number, okay? So, okay, could I use, what if I looked at the sine cosine of all, and all the trig functions of the reference angle? So if I do sine of pi over 3, and then I do the other trig functions, so let me just write those out. Okay, I wrote them out. Sine of pi over 3, you might need to review the point, the trigonometric point that corresponds to pi over 3. So if you just do p of pi over 3, this would be equal to 1/2 comma square root of 3 over 2. Okay, so sine would just be square root of 3 over 2. Cosine would be 1/2. Tangent would be square root of 3 over 2 over 1/2, also known as square root 3. I'm just drawing a line there to separate these things. See, square root of 3 over 3 if I simplify, and then 2 square root of 3 over 3 if I simplify here as well. So now I just want to compare these things, right? They're very, very similar, right? If I look at sine, for instance, they're off by a sign, S-I-G-N, like a negative sign, right? So if I had a negative here and a negative there, these things would be equal, right? Cosine, they're the same. Tangent, tangent is the opposite sign, okay? Cotangent is the opposite sign. Secant is fine, and cosecant would be the opposite sign, okay? And so why are these off a little bit? And it's because when we use the reference number, reference angle, that's always an angle in quadrant 1. In reality, where are we? We're in quadrant 4, okay? So if I use the reference number along with the signs corresponding to the quadrant that the actual angle is in, I'll get equivalence, Okay, so this is the second strategy, to use reference numbers. Okay, and that's kind of the step process that I have here down here. So find the quadrant that theta is in, find the reference angle, evaluate the trig function at the reference angle. That's what we did for sine of all the things for pi over 3, and then include the appropriate sign based on the quadrant. Okay, and that's what I included in red here. Okay, so this is our second method. In addition to just using the plain old trigonometric point. Students in the past say, well, why do we need this method? We can just have our unit circle, our completed unit circle. I'm like, yeah. Maybe you just, the upshot of using this reference number method is that you only have to remember quadrant 1. And then as long as you can find the reference number, you always get to something in quadrant 1 and say, okay, well, I know everything in quadrant 1, and I know my actual things in quadrant 3. Okay, slap on some negative signs in the appropriate trig functions because of quadrant 3. Okay, that's kind of the upshot. Okay, all right. Next example. Okay, we want to find the 6 trig functions at 11 pi over 4 using reference numbers, and you get a little extra bit there. Okay, so 11 pi over 4. Okay, what I see this as is it's 8 pi over 4 plus 3 pi over 4, which 8 pi over 4 is 2 pi, and then I have an additional 3 pi over 4. So this is telling me you go one time around for the 2 pi, and then you go 3 pi over 4 more. Okay, so I can imagine my unit circle. I go one time around, and then 3 pi over 4 more, landing in quadrant 2. So this is my theta of 11 pi over 4. If I want to find my reference angle, that would be this much here. So that's my theta prime. And then I get my reference number t prime. Theta prime, the distance I'd have to go, or the angle that I have to go to get to the x-axis, or the distance along the unit circle I would need to travel, is just pi over 4. Okay, so if I want to find, say, sine of 11 pi over 4, okay, I can do sine of pi over 4, my reference angle, and then in quadrant 2, sine is positive, right? So I have a negative x, positive y, so then sine is going to just be positive. Okay, so this is just going to be, and I know, maybe I know the trigonometric point, I should write this out, p of pi over 4, I know that to be square root of 2 over 2, comma, square root of 2 over 2. Okay, so then I just do positive square root of 2 over 2, and I move on to cosine of 11 pi over 4. Okay, I could use the reference number of pi over 4, and then in quadrant 2, where I end up, cosine is negative, so I include that negative there, and I have negative square root of 2 over 2. And you're probably like, Professor Bright, just use the coordinate from the unit circle. Yep, we can. I have to read the damn directions though. Okay, so follow instructions. Okay, very important in your future job. If you don't, your boss will not be happy with you, right? And here are the other trig functions. And there you go. Oop, this should be positive for cosecant. Okay, so tangent, again, you can look at tangent 11 pi over 4, say that's tangent of pi over 4, but negative because, again, y over x is negative in quadrant 2. Okay, cotangent, reciprocal, -1 also. Secant, negative because x is negative in quadrant 2, so your final answer is negative, and something similar for cosecant, just that it's positive because sine is positive in quadrant 2. Okay, so reference numbers, big idea. You can use the reference number for any angle that you're working with in a trigonometric function, and the trigonometric function at the reference angle will be the same as the trigonometric function of the angle, as long as you incorporate the sign of where the terminal edge of the angle lands. Okay, so there we go. We'll get some practice with this in class.